Morning, everyone. Thanks for joining us. This is our second in the series of Coffee with the Casco Baykeeper, but we're affectionately on staff calling it Science and Cereal because we all often, when we're going out in the field, meet with our jars of overnight oats. So I don't know if you can see it, but all three of us have jars of overnight oats with us. But we promise not to eat while we're on camera. that
Wait
would
till
be
we're done.
that would be sharing a little too much information with you to watch us shoveling the oats in our mouth. But we're super glad you're here with us. So this is our program team. This is the team that goes out and collects data. Mike continues to be our lead scientist, but all of us are in the field playing different roles. And Mike, let me start with you.
Sure.
You have been leading Friends of Casco Bay's science efforts for about 3 decades now.
A number of years, yes.
Number of years, yes. What has changed over that time? And I just mean at a high level, not like a whole dissertation, but at a high
Yes.
level, what has fundamentally shifted?
Absolutely. For our water quality monitoring efforts, I think that the question is the thing that has changed. Early on, we would go out, look at the health of the bay, and ask the question, how is the bay? And we did that, and we continue to do that now. That's still a very important question. But along the way, we evolved our program as the question changed. We started talking about or asking, how is the bay changing? And we added to our water quality monitoring programs a continuous program, which we'll talk about. And now finally, we're talking about how is the water quality of the bay impacting the things that live in the bay. And we'll talk about eelgrass specifically later on this morning.
That's a really pretty significant shift.
Yes.
With these changes in priorities, are there any changes in where and how we're monitoring?
Sure. We want to pull a map up here. We can look at Casco Bay, of course. And very, very quickly, the blue and green dots are where we go out once a month, May through October. So seasonally, we call this our seasonal water quality monitoring program. Those green dots are actually over eelgrass beds. And you'll hear more about that coming up. But we look at water quality once a month at all of those sites. The yellow stars are our continuous monitoring sites, and we collect data every 15 minutes year round at those stations. And that was in response to how is the bay changing?
Excellent. Okay, Sarah, this predates your time, and the person who used to run our citizen science program I know is attending this webinar. Shout out to Peter Milholland.
Morning,
But
Peter.
Sarah, our citizen science has also shifted to people helping us track the health of the bay, to helping us document the impacts that changing conditions are having on habitats and species. Can you talk a little bit about that, the shift, the even finer point shift between 2024 and 2025 in the Water Reporter program?
Yeah, so our Water Reporter program, for those who don't know, is a community science program where folks have an app on their phone and they take photos of observations throughout Casco Bay, which, as Ivy said, really helps us look at the habitats and how the water quality is actually impacting the ecosystem. So in the last couple of years, we have implemented a new app that is much more robust than our old app. Some of you who have used both are really happy with our new app, and we are too. And part of that reason is because the software that powers this new app allows us to do a lot more with the data so that we can analyze it alongside the data that Mike is getting from the Bay. So we'll show you a little bit of that later on.
And ironically, thank you, water reporters who are listening. It's working
Absolutely.
so well, and our water reporters have documented so much that we're trying to figure out how to increase the capacity of the photos with Water Reporter, right, Sarah?
Yep. Yep.
Okay, Mike, I know everybody's been waiting to look at our data. So let's start with the seasonal program. Uh, can you
Sure. And I
talk a little
can,
bit about temperature data for 2025?
yes, I can. But before we get there, I just want to quickly introduce another member of our team, the data sond. This is how we collect the data. And then we'll jump right into temperature and seasonal monitoring. But We can't continue without sharing a look at one of the most important members of our team. This is a multi-parameter monitoring instrument. We use it in both that seasonal water quality monitoring program, uh, dropping this over the side of a boat or off a pier like I'm doing here. But this is also the same instrument we leave at those continuous stations to collect data every 15 minutes. So it's very versatile, collects a lot of different information about the health of the bay. So I just want
So
to share an
before
unsung
you
member
go
of the team.
on, yes,
Yep.
before you go on, I think I was remiss in not remembering this because no data presentation is complete without a photo of you and your sond. Like
Right.
We have
such great,
hundreds.
yeah, we need to
Yes.
have you like through the years with your sond. And
Oh
also
no.
like it's nice to see the labels for all of the different pieces of information or parameters that you're collecting in the field. And then our sond, they've improved. Is that the wiper that I'm seeing where there's that arrow? Or is that a wiper on the end
It
that
is on
helps?
the very top. Yeah, the far right of that close-up image there. Yes, thank you. So the questions and the approach has changed over the years, but the instrumentation's been roughly the same, but it has gotten better. And that wiper is one of those improvements. When we leave this in the bay at those three continuous stations, you can imagine things start to grow on these sensors. And that wiper will spin around and clean things off, and it does a remarkable job. So the technology has improved, even though it's still the same type of instrument we've always used.
Yeah, it's one of the exciting changes in technology, and it's one of the we're fortunate enough to be able to have dialogues with the manufacturers of equipment and sometimes get to test out new equipment or
Yes.
recommend advances. And this wiper was certainly one of the advances that we had hoped for and that industry responded with. Okay,
Yep.
so now the data.
Yes. So at long last, um, we're going to start with a look at some of our seasonal water quality monitoring data. This is again where we go out once a month, May through October, and you're looking at a graph of the entire time we've been monitoring water quality in Casco Bay. So at the bottom of this graph, you'll look at 1993 right through last year at 2025, moving from left to right. And again, you're looking at water temperature. And you may have noticed things were a bit cooler last year in Casco Bay, and that dot represents the annual average for 2025 at the far right of this graph. So we were a bit cooler, and we may see a few more years where we're a bit cooler, but the trend remains up. We are getting warmer in Casco Bay at a rate of about a degree Fahrenheit per decade, or over 3 degrees on average since we started collecting data. So it includes 2025 data at the far right there, but really is a look at how we compare to the previous years. And we are getting warmer, and that is of concern.
It's interesting too, because even though for many of us it feels like, oh, this is like a really classic um, year or was a classic year in terms of a cold winter, it's
Yep.
still not as cold as some of the prior really cold winters.
Right.
But Mike,
Exactly.
before we move on, what was the coldest temperature that you recorded in the winter of
Sure.
2025?
Through our continuous program, we saw temperatures below zero frequently, especially in February, getting as low as negative 1.8 Celsius, which is high 20 degrees Fahrenheit. So very, very cold.
Wow. And uh, just for reference, we'll talk about continuous monitoring later, but
Yes.
those are recorded at 4 meters down. So if you have
Correct.
temperatures that cold, 4 meters down, you can imagine what it's like at the surface or when we see frozen surfaces in the ocean.
Yes,
Okay,
exactly.
Mike, there's so much synergy. Like understanding one element is just not enough to understand the health of the bay or how it's changing. So let's go on and look at dissolved
Yep.
oxygen.
Yep. So we use a number of different things to assess the health of the bay. And again, this seasonal program allows us to go out and like a checkup, like an annual physical. How is the bay on that day? This graph, first across the bottom are the names of those blue and green dots you saw on the map. These are all of our seasonal sites. What we're looking at here is something called dissolved oxygen. Everything in the bay, all the critters need oxygen, just like we need oxygen. So it's very important that we have enough of it in the water. We're looking at oxygen as a percentage of what could be in the water at a certain temperature and salinity. And so we want to be at least around 100% saturation. That red line at 85% is a state criteria. We certainly don't want to be below that. If you have too little oxygen in the water, all the critters are going to become stressed. So as you can see, things are pretty good where we monitor in Casco Bay. Those average values are close or above 100%. Even at the far left of this, at the sites that might have slightly lower water quality, it's still pretty good when it comes to dissolved oxygen. So an indication that even though we're getting warmer, there are some good signs. The bay is pretty healthy.
Mike, though, before we move on or just think things are pretty good, this seasonal program is just collecting data,
It's a
six
checkup.
times over the summer?
Correct.
And also, because we're shifting to monitoring eelgrass, we're going out later in the morning to catch
Yes.
light, which you'll talk about later. So can you talk about the impact of monitoring sort of during the sunniest part of the day and what you might expect that to do to dissolve oxygen levels?
Right. We're going out there, especially those afternoon monitoring events. We're getting conditions at their best when the phytoplankton has and all of the algae has gone through a day's worth of photosynthesis, producing oxygen. So you have a lot more oxygen in the water. If we were to go out early morning, perhaps we might see something completely different. So yeah, this is again, it's just a quick checkup. It allows us to get out on the bay by boat and see the sites, to physically be there. Yeah, so for these sites, when we monitor, things seem pretty good. But these are all boat
Excellent.
sites, of course. There might be some areas closer to shore that might have some issues as well.
Okay. Well, now that we've looked at your friendly little sonde, let's move on to another
Yes.
piece of data that the sonde collects, which is chlorophyll.
Chlorophyll. And chlorophyll is, of course, the green pigment in plants that allows it to go through photosynthesis. We use chlorophyll as an indicator of the health of the bay because it's a good way to estimate how much phytoplankton is in the water. Phytoplankton are those microscopic algae that are the base of the food web that produce a lot of oxygen. And so, of course, to be a productive bay, we want a lot of it, but not too much. This is one of those things where you want some, but not too much. And that's what we're seeing here for 2025, again, when and where we were monitoring. Concentrations in micrograms per liter of chlorophyll between 2 and 4, maybe 5 is a very healthy, productive bay. There are spikes above that, of course, from time to time that we expect seasonally. We just don't want a lot of phytoplankton, a lot of organic matter in the bay for long periods of time. And at these sites, we weren't seeing that last year.
Yeah, interesting, because we've had other years where we've seen a lot of blooms, but this year we didn't, in our
Correct.
seasonal monitoring, capture that.
Yep.
Sara, when we have captured high levels of chlorophyll, what have our water reporters noted?
Yeah, so when there's high levels of chlorophyll, we often have water reporters sending in photos of brown water. Our bay, that's usually more of a blue or green or clear, will be really brown. And brown is a concerning color, right? So people get concerned, they post photos, and often that just means that there's a large phytoplankton bloom. So it's not necessarily unhealthy, but it just shows that there is a lot of phytoplankton. And so when you send in those photos, we compare that to our chlorophyll data to back that up and confirm, which is pretty cool.
Well, another thing that's really important about our water reporters doing that is that, I mean, the color of the bloom could be it could be different colors depending on the type of phytoplankton. But when these brown patches are reported, sometimes it could be a type of phytoplankton that is harmful to the bay, a Karenia bloom. And so we'll often also report that to the Department of Marine Resources, who does a little more investigation to make sure there's nothing concerning in the bay. And other times it might be a signal of a big push of stormwater coming into the bay that's discoloring it versus a phytoplankton bloom. So we really appreciate those reports, right? Because it helps us then as a staff go out and figure out what's going on.
Exactly.
Okay, Mike, I know you love your sonde, but we also collect water samples that we analyze. Can you talk a little bit about the sampling we do for total nitrogen?
Yes, as absolutely. As part of our seasonal work, we also collect water samples for nitrogen analysis. And we're looking here at what's called total nitrogen to measure of all the nitrogen species in the water. And it's similar in aspect to the chlorophyll. We want nitrogen. It's an essential plant nutrient. We got to have it. We just don't want too much of it. And what we're looking at here is three sites, the three sites we've been to the most through our seasonal work. It allows us to show nitrogen data going back to 2008. So we're getting close to 2 decades worth of this data. And the two takeaways here are first, there's a red line at 0.32 milligrams per liter of nitrogen. And that's a generally accepted threshold. If you get concentrations above that, you start to see some negative impacts. So we want our data below that, and we definitely see that we're generally below that line. And over time, we've seen a little less nitrogen at these sites offshore in the bay. So nitrogen is what provides food, if you will, for all the algae in the water. So we got to have it. We just don't want too much of it.
One thing that's interesting to me about this slide, well, there's many things that are interesting, but one of the many interesting things is Broad Sound is sort of what you call, Mike, a reference site. Can you talk a little bit about what it means to have a reference site so that then when we look at the levels at like Fort Gorges, which is obviously right off Portland Harbor, or Clabber Island, which is off of Falmouth, then how you can look at this data to kind of try to figure out what might be nitrogen loading from land-based sources?
Yes, absolutely. Broad Sound is our site that is furthest offshore. So we do consider that more of a reference site. It has a lot of open water, a lot of ocean influence, offshore influence. It's also our deepest site. So you'd expect a little less nitrogen out there than you would close to shore. And as you noted, Fort Gorges is right off Portland Harbor, right off the mouth of the Presumpscot. A lot of urban contributions there of nitrogen, so that might be a little higher. And Clabber Island, more of a suburban area, I guess. Still inshore-ish, but not right in the middle of the harbor. So it does give us three different ways of looking at what we're seeing in nitrogen.
Excellent. There's so much I could talk about with this slide, but I know we have a lot to cover.
No.
So I'm going to force myself to move on and not do what we do when we're in the truck and we talk for a long time. Sara, again, when there is too much nitrogen, especially when levels are above that, I'm going to say 0.30, because we start to see impacts before that 0.32 milligram threshold that was in a red line. What do our water reporters document? And the slide is already up, so it's kind of like, I think people can guess.
Yeah, so the nitrogen samples that we take are mostly from our vessel. So even if we're close to shore, we are somewhat offshore. We're not right in this intertidal zone in the mudflats. And so water reporters really help us to see what's going on right offshore. So this is at a really low tide, right behind Hannaford in South Portland on Cottage Road. This is Mill Cove, and this is a nuisance algal bloom. So we qualify a nuisance algal bloom when there is so much algae that it is really green and thick like this. If we were to go out there, we would be able to pick up like a thick clump of algae. And this is a result of too much nitrogen in the water. So the graph we just looked at, those are grab samples, those are averages across the whole season, whereas there's a lot of fluctuations of land-based nitrogen closer to shore. So that's where water reporters really help supplement our knowledge. And when we see algal blooms like this that are persistent, it allows us to do investigation about where those excess nitrogen sources are coming from.
And this is a bloom that we're investigating right now and trying to figure out, right, Sara?
It sure is. Yep. And thank you so much, Joyce Murdy, for your consistent reporting at this bloom. It really helps us get to the bottom of it.
One more thing I think that's worth noting before we move on is harmful algal blooms are those types of phytoplankton blooms that can cause illness or sickness. So we're distinguishing this and calling it a nuisance algal bloom because the algae itself won't make
Right.
someone sick if it was consumed or something like, well, no, I shouldn't say that. Harmful algal blooms are the things that like impact oysters and things like that, that shellfish that we don't want to eat. But this is different. It's a nuisance situation. Right, Sarah? Yeah.
Yeah, definitely. And why nuisance algal blooms are a problem is because they smother the clam flats. And so,
Yeah.
although they're not harmful for humans, they are harmful for the critters that live in the mud flats. And it just throws the whole micro ecosystem off right there.
Yep.
Yes, it depletes the dissolved oxygen in
That's
the mud
Yeah.
flat, it lowers the pH, and it kills the life that lives there. Thank you for helping me as I was stumbling to articulate the question.
And generally, the harmful blooms are more microscopic phytoplankton,
Right.
the nuisance
Yes.
larger macroalgae, the seaweeds.
Yes, thank
Yeah.
you. I just wanted to sort of like, we talk about HABs, the harmful algal blooms, and then the nuisance algal blooms, and I don't think we take a moment to really define that. And I thought we should.
Right.
And
Yep.
I thank you both for helping me as I was stumbling through the question. Mike, let's go on to a new parameter that we measure. Well, it's not brand new, but we're consistently doing it now,
Yep.
called KD.
Oh,
Oh,
actually,
go ahead, Sarah.
yeah, we'll let Sarah finish and then
Ivy, I think maybe you could use another sip of coffee.
Do y'all think I should switch from decaf? Do you think that maybe? Okay.
Okay, so really quick, so the photo we just looked at was one photo from a water reporter, right? And that's really helpful for identifying one site and what's happening at that one site. These are two maps, as you can see, one from 2024 and one from 2025, comparing algal blooms throughout the South Portland region. And this is where the aggregate of data really helps us see patterns. So each photo we consider one data point. And when we look at it in the aggregate like this, it helps answers questions that we can compare then to our quantitative data. So in 2024, we had a lot more medium-sized blooms throughout South Portland and Portland. And in 2025, we had fewer overall nuisance algal blooms. And instead, the algal blooms that were there were much, much larger and more intense. So this is a really neat way that we're using our new Water Reporter software to glean more data over time.
Thank you. Can I talk about KD with Mike now?
actually not yet. First, we're going to talk about temperature eelgrass, but I can kick off eelgrass, which is still kind of part of our seasonal work now. The next slide looks at a way we look at temperature. In addition to our regular seasonal work, we're more and more concerned about the health of eelgrass. Eelgrass is a critically important habitat in Casco Bay. Casco Bay used to be fortunate enough to have some of the largest and densest beds in Maine or the eastern seaboard, really. And it acts as an important nursery and habitat. It stores carbon, so it slows down acidification. It anchors sediment to prevent resuspension of sediment. It reduces wave energy. I can go on and on. It's a really vital habitat and so important that the DEP, the Maine Department of Environmental Protection, maps it every 5 years. And between the last two mapping efforts, we realized that we had lost over half the eelgrass in Casco Bay. And so it's become a really big issue for us, for a number of people. We're part of a large collaborative effort to figure out why we're losing it and if we can restore it. So we're a little more attention spent around eelgrass beds. And one of the ways eelgrass may be being lost is because we're getting too warm. There are a number of water quality measures that we're looking at to see if it's impacting eelgrass. Temperature is one of them. The graph you're looking at here shows data from those three eelgrass areas that are part of the seasonal work now, the Mackworth site, the Broad Cove site, and the Cousins Littlejohn site. Eelgrass has a happy temperature range with a maximum of around 20 degrees Celsius. As you can see from these temperature sensors, and these record temperature every 15 minutes as well. These sensors are placed on the bottom of these three areas. And you can see that we had temperature readings at depth where the eelgrass are, where they live, is above 20 for July and August, and even up near 25, which is kind of a real upper threshold we don't want to get near. So even on a cooler year like last year was, relatively speaking, of course, we're still seeing temperatures that might stress eelgrass.
Mike, can you talk a little bit about like this hobo sensor? That's something new for us,
It
and
is.
it's like a continuous collection of data. Can you talk a little bit about how we're deploying those?
Thank you. Yes, it's a really a very simple temperature sensor. It's been around for a while. It can store a lot of data. You can just secure it to a cinder block, perhaps, as we will, and leave it at depth. And it'll just run and collect data on temperature as frequent as you'd like. We do every 15 minutes to match our continuous data. And it's just a great, simple way of getting a lot of information, especially about temperature, where it is one of those critical water quality things that impact eelgrass.
And Mike, the other thing about temperature that's interesting is um, can you describe a little bit about the nature of eelgrass as a flowering plant and why tracking temperatures during the summer season is so important for determining its health?
Yes, and I will just add on to what you were just talking about. Hobo is simply the name of the device we use. We could have just said continuous temperature sensor or something. I didn't want to throw everyone off by saying hobo. It's the manufacturer's choice of term for this device. But eelgrass is a true flowering plant, and it has a pretty limited range of how hot it can get. And I think that's why we're concerned as a species. It can live in warmer temperatures. You do find this same species of eelgrass to our south, and one of the things we're wondering is if those subspecies, I guess, might survive better up here as our waters continue to warm.
Yeah, like for example, in at the end of 2024, one of our colleagues, Team Zastra, did some seeding and planted
Yep.
some eelgrass in at some of the sites, and there was germination, but then over the summer, a lot of those young shoots died off. And so there is this question of like, why was it related to temperature? We don't know yet, but like
Right.
that's why it just feels like tracking this and the timing of when we're seeding and all of that is going to really tie into all of this. Sarah, do you have anything to add from the water reporter perspective?
Mhm.
Yeah, so once again, water reporters have been very helpful in helping us track the health of eelgrass throughout Casco Bay. So eelgrass is an intertidal species, which means from shore you can really only see it when it's a really low tide. And so we send water reporters out at really low tides to take photos of eelgrass. And these two photographs taken by water reporter Ann Wood really show you how water reporters can help us track eelgrass over time. So the photo on the left is in 2020 and the photo on the right is 2024. And you can see that this is at Falmouth Town Landing, and you can see that the dock is really, really helpful in aiding the comparison of the two photos. So you can really see that that large patch of eelgrass there disappeared between 2020 and 2024.
So a couple of things that's interesting about this or worth noting is the period of time that Mike was talking about was between like 2018 and 2022 when the Department of Environmental Protection's mapping noted a 54% loss in eelgrass. But that loss has continued past 2022. And this is a site where that is well documented.
Yeah.
And what's also, Sarah, can you comment a little upon like what that leaves the quality of the mud like now that the eelgrass is gone at Falmouth Town Landing?
Yeah, so eelgrass really helps to keep the sediment in place. So when we have storm surge, the sediment stays in place, and the quality of sediment really provides habitat for intertidal creatures that live in the mud. So you can see here that the mud is a slightly different consistency in the photo on the left and the photo on the right, which is just an interesting thing. So we can, from these water reporter photos, there's more to glean from them than just the loss of eelgrass. We look for other signals as well in the surrounding photo to put together the pieces of the puzzle.
What else have water reporters noted about eelgrass? Anything else, or?
Well, eelgrass, as we said, it lives underwater most of the time, so it's really hard to see. We do have partners that go and dive and look at the eelgrass, but they can only look at really limited areas of eelgrass because of capacity. And so water reporters do also take up close photos of eelgrass, which really help us assess the health of individual beds. So on the photo on the left, you can see there's some epiphytic growth. Epiphytes are things that grow on other things. So you can see the fuzzy, maybe algae or hydroids on the photo on the left. And then on the photo on the right, we can see snails on the eelgrass. And we're not biologists. We don't necessarily make a determination of what's healthy and unhealthy, but we share all of this data with our partners and are in conversation a lot about the health of eelgrass using water reporter photos.
Yeah, that's an interesting comment before we actually go on to discussing KD, which we'll get there. That question about what is healthy, that is a question that we have been asking a lot in collaboration with our partners, because we have a firm understanding of what's healthy based on historic information of eelgrass, right? Like, we had the most extensive beds in probably the North Atlantic, and our eelgrass beds looked like the photo on the right that you took, Sarah. I mean, I remember wading through eelgrass just to swim with my kids in Broad Cove. And now it's changing. So, like, how do we define healthy moving forward? And that's part of the translation of how we're using our data to policy, and parts of conversations and work that we'll be doing over the next couple of years to help try to define that, so we can help try to make eelgrass resilient and present into the future. So, Sarah and Mike, can we talk about KD now?
Let's find out.
Go for it.
As eelgrass is a true flowering plant, it needs a lot of light. So another way we look at the water around eelgrass to see if it's healthy enough to support eelgrass is light availability. We want to know how much light that is hitting the surface of the water gets through to down to the bottom where the eelgrass are. So we're looking at how much light that is hitting the surface is being blocked from getting to the bottom. KD is simply the light attenuation coefficient. Don't worry about that. We want small numbers here. And there's a column on this graph for each of those 3 eelgrass sites. Lower numbers around 0.4 is very good. There's not a lot of light being blocked from getting through. So there's better light availability to the eelgrass. It's sort of counterintuitive. Where you have higher numbers, more light is being blocked from getting down through the water to the eelgrass. Less light is available. And at Broad Cove, the column in the middle there, you can see that it's higher than the other 2 sites. So less light is getting through, but it's still below that red line at 0.75, which is not a hard and fast line. But above that, we start to worry that not enough light is available to eelgrass. We're not there yet, but Broad Cove certainly gets close from time to time.
Mike, I'm going to ask you a couple fine point questions about this slide. There are black bars on each of these, and let's look at Broad Cove's black bar. Can you explain what you call that black bar and then what that indicates?
Yep, that is a standard deviation bar. It's a measure of the variability around the average. So the columns themselves, the top of the column is the average of all of the data we collected last year on light at these 3 stations. The black bar represents how close to that mean we were always seeing. So that black bar, the standard deviation at Broad Cove, is bigger, larger, higher than the other 2. So there's more variability around that average. So there were times we had not a lot of light if you're close to the upper reaches of that bar.
Right. And so that's important if for people looking at this slide to know, because again, this is from our seasonal data, so it represents 6 points in time.
That's
And
it.
there's a standard deviation that's getting toward that threshold, which suggests that there may be some issues here in terms of healthy eelgrass habitat. Mike, historically, Broad Cove has had one of the most persistent and important eelgrass beds in Casco Bay. And I know we've got people from Eastern Casco Bay on this program as well. And we had originally intended to study McCoy or Middle Bay, but we couldn't because all the eelgrass disappeared. And
Right.
so what happened in Broad Cove between the time we identified studying that bed in 2023 and the start of our eelgrass study in 2024?
Right. Unfortunately, there was no more eelgrass in Broad Cove when we set out to study it. It had eelgrass at the most recent mapping effort. So it was selected as a place to go look for the water quality around the eelgrass. And when we got there, the eelgrass had already disappeared. So we've lost more than that 54%. It's getting worse every year. But ironically enough, or maybe not ironically, but losing eelgrass at Broad Cove meant that we lost what eelgrass provides in locking down sediment. It allows that sediment to get mixed up with the tide. And that may be why we're seeing less light availability there. That column shows there's less light getting through, and maybe because the eelgrass is gone in the first place.
All right, so it's kind of like a chicken and egg situation,
Yeah,
and
yeah,
we got to
feedback.
figure out if we can restore eelgrass there at some point.
Yep.
Sara, turning to the water reporter front, can you talk a little bit about, as we're out in the field with other scientists studying aspects like green crabs and health of the eelgrass and all, what are our water reporters doing?
Yeah, so as we've learned, Maine DEP maps eelgrass every 5 years, and a lot is happening in those 5 years as we've learned, as we've studied eelgrass the last 2 years. So we have conducted seagrass snapshots. We've done 3 in the last 2 years. We'll be doing another one this July. And what that is at a low tide, we choose a low tide that's over the period of a few days during daylight. And water reporters choose a site, and everyone goes out around the same time during that low tide over the course of a couple days and photographs whether or not there is eelgrass in that location. So not only are water reporters uploading a photo, some of which have eelgrass, some of which don't, but they're also marking presence or absence. So you can see here on the map that green means presence of eelgrass, red means no eelgrass seen. So this isn't conclusive data, right? This is observational data where someone didn't see eelgrass. There may be eelgrass there. It just may still be under the water, or they didn't identify it correctly, which happens, but it does help supplement the DEP data. And this has really informed our science team and our collaborators about where to research next and
Yep.
where to look for new eelgrass beds or potentially eelgrass beds that we thought were there and no longer are. So we have more about this on our website. You can check that out and join Water Reporter if you want to join our seagrass snapshot this summer.
Yeah, this is, it's so interesting. One of the things we don't have time to talk about, but we'll be reporting on next year, is we are now part of an even bigger grant to study the health of eelgrass in Casco Bay. And as the seagrass snapshots are so important because it begins to help us tease out questions like, wow, it looks like there's more eelgrass at the places that are cooler and a little bit more offshore, or maybe there's not so much land-based loading of nutrients and other or areas where green crabs are. So this
Right.
is just so helpful, and is more and more something that the scientists are looking at to compare with the data that they're collecting in a kind of a Western science way. So big shout out to our water reporters who are getting a lot of attention, not just in Maine, but through a network of scientists working to restore eelgrass really along the eastern seaboard. We have to move on to continuous monitoring, the
Yes.
workhorse of our system. Mike,
Yes. So this is we have about a decade's worth of data now at our continuous monitoring program. This is what we went to when we knew we needed more data to really understand change in the bay. And this is those three gold or yellow stars. I think of them as gold stars. Those three stations spread across Casco Bay. Each one has a station collecting data every 15 minutes, as we noted, year round. And I want to introduce this graph because you'll see a few of them now, but also to encourage you to go to our website. We have a map like this for each parameter, for each station. So there's a lot of information there. The graphs are all very similar. You have the months across the bottom for the year. So January to the left, running through December to the right. So you're running through the year. We're looking at water temperature at our station in Yarmouth. The dark blue line through the middle is data from last year. It's always the most recent data. The gray area behind that blue line is the range of historic data. So the maximum values and the minimum values of the daily averages, which is what you're looking at here. So I just want to introduce the graph and also call out, you can see that the dark blue line in February, March, and then also in December falls below or at those historic low temperatures. So looking back, and this is just 10 years of data at this site, but last year's data really fell out close to the bottom, the colder temperatures that we noted earlier. But this really gives us a look at the variability in the data around those Ivy, as you said, those 6 data points, those 6 monitoring events through our seasonal work. We're getting data on how the tide influences things, how seasonality really impacts the data we look at. So anyway, temperature, and I can certainly
yeah,
go.
and just for reference, because I know you'll talk about it a little bit later, but you can see that there's some breaks in the blue line, and I just want people to note that because I know you're going to talk about something later that about that. So, Mike, let's go on. Let's talk a little bit more about continuous
Yes, I was hoping
monitoring.
nobody would notice, but yes, no. If we can quickly move forward.
Next slide, please.
So the next slide is again, you'll see this type of graph with the months across the bottom. So you're working through the year, the dark blue line for the current data or last year's data in this case, and then the gray historic data behind that. So just to familiarize yourself with how we're presenting the data, these are on our website. We're looking now at dissolved oxygen, which we talked about earlier, still as a percent of what could be there. This is data from our Harpswell site. The one thing I want to point out real quickly is that historic range in gray is a bit more narrow here, and that's because there's just not as much data. We've only been at this site and the Portland site for about 5 years now, so they're about half the age of our Yarmouth site, but growing. And what I want to point out here are 2 things, 2 take-home messages. You see the red line at 85%. We talked about that earlier. That's that state criteria. If your oxygen levels fall below that, things may not be so good. And we really only get down that low for a few measurements in October there. Yep, where the cursor is. So it is something we track, something we watch, how many measurements are below that criteria. But the second thing I want to point out is how we're above 100% for a lot of the summer. All the algae, all the phytoplankton producing a lot of oxygen in excess of what the capacity of the water to hold is. So you get these super saturated summers. But then as you get into fall, from August, September, October, you see that ramping down of oxygen levels as there's more respiration, there's more decomposition of all of that organic matter. As you move into fall and winter, the breakdown of all of that matter leads to losing oxygen in the water, so lower concentrations. But again, just something to track online on our website.
Yeah, and I want to get on to omega aragonite, but
yes.
I think that in making that transition, this shows why it's so important to have continuous monitoring, because the 6 data points for dissolved oxygen does not show that seasonality in those trends.
Yes.
So important to have made this transition to continuous monitoring. Okay.
And this is something, what we're going to talk about now is a measure of acidification. We spend a lot of our time tracking coastal and ocean acidification. I'll introduce the parameter in just a second, but I just want to note that it's the same graph, same kind of thing you'll see on our website. One of the ways we measure acidification, of course, we do look at pH, but there are other ways to look at how our bay is becoming more acidic. One of those ways is omega aragonite, which is simply the amount of calcium carbonate in the water in Casco Bay. And you may wonder why we care about calcium carbonate. That is the material that shells are made of. So all of the shellfish depend on the amount of calcium carbonate or aragonite in the water. Acidification will lower the amount of calcium carbonate, so there won't be as much material in the water for shellfish to build shell. So if you like oysters like me, or mussels or clams, we might be looking at in a more acidic environment, it might be more challenging for these shellfish to build shell. And I think the modeling now indicates that by 2050, we might see aragonite levels, omega aragonite, down below that 1.5 threshold most of the time. As you can see, we're above that 1.5, which is what the shellfish really need to really build shell. And we get that during the growing period, but it really falls off in the fall and winter and starts out low as well. So we're okay now, but it's definitely something we monitor. And we don't want to see that those values go down as the baby becomes more acidic.
And Mike, could you quickly, because I want to leave time for questions, talk about
Yes. Oh, yes.
the sensor squad, and
Yes.
and then maybe Heather or someone can share a link to the sensor squad report in the chat. But just quickly, like, why we're so excited about this data at this point in time in 2025.
Yeah, so thank you. Another reason I wanted to share this parameter in this graph is that we are working through a collaborative effort with the University of New Hampshire, with Wells National Estuarine Research Reserve, Casco Bay Estuary Partnership, now DEP, DMR as well, in trying to make sure that we're getting the best and most accurate data we can, specifically for acidification. This parameter is something we calculate, so we need to be really, really careful with the accuracy of the things we measure to make the calculation. Then, of course, how we're calculating things as well. So this sensor squad has really allowed us to improve the quality of our data. It continues to do so, and making sure that we're confident in what we're sharing with the public.
Okay, so to put a very fine point on it,
Sure.
the collective scientific community now feels confident enough about the quality of this data that it can be used for management decisions and policy decisions. And we're super excited about this.
Thank you.
And
Yes.
we'll hold a meeting of a collaborative that we've put together. It's wholly voluntary in April to discuss next steps on the science monitoring, which is pairing it with biological response and creating a 3-day ocean acidification forecast that say a oyster farm could use to figure out what to do with its product, and just all the policy implications as well. So very excited about this. Mike, I'm going to ask you a question about this to sort of transition us into questions. And that is, again, for our observing audience, they're going to notice breaks in these blue lines. What have you added at the Harpswell Station, thanks to funding from the Casco Bay Estuary Partnership, that's going to help eliminate those breaks?
Yes, so and thank you to the Casco Estuary Partnership.
Yeah, so we go on to the next slide, I guess.
Yeah, well, yeah. So those gaps you noticed that were most prevalent in that last slide indicate when a sensor has failed. We deploy our equipment for 3 weeks, and generally in the past, you put the sonde in the water, you let it run for 3 weeks, you bring it back, you upload the data. If a sensor has failed, it's failed. You didn't know about it until then. And that large gap you saw, I think it was in the spring, in that we had back-to-back 3-week deployments where a sensor had failed. So we had a month and a half without data for a number of parameters. It's my biggest nemesis. I don't like data gaps, and we've always done everything we can to get around it. But we now have telemetry at that Harpswell site, so we will know if a sensor fails. We'll reduce the size of those data gaps to just the amount of time it takes us to get up there and swap that sensor out. So telemetry means real-time data, which you can access on our website. This is actually a screenshot from our website. If you go there, You can click and see data live from the sonde at that station. Not just the sonde, though. We have some weather measurements as well from a weather station. That's right there. That's Heather and I pulling the station and attending to the black box of telemetry. But this is great. It's I do tend to look at the link far more often than I should, especially at 2 a.m. if the wind's blowing and there's a storm. I'll take a look. But it's great. And this is still stock software. The interface here isn't as great as it's going to be, but it is
Okay.
available. You can go and see the
It
data.
is available. Okay,
It is
so let's
available.
see. I'm so glad our audience has asked questions that I wish we'd had time to get to. So I'm going to start with, how does the current harbor dredging project affect water quality and marine life in Casco Bay?
So we are actually tracking turbidity around the CAD cell where their dredged materials is deposited to. We could spend a whole hour on CAD cells and dredging, but I can say right now that through our monitoring and through the monitoring of EPA and others, we're not seeing a lot of turbidity, a lot of suspended sediment around dredge operations. So there's not a lot of sediment falling out and impacting marine creatures. So things are good, is the short answer.
So I'm going to ask people to respond to this in the chat. Is that data also something you'd like to see on our webpage? So if people want to also know more about the dredge, because we can talk about that data next year. We've just begun that
Yes.
monitoring.
Yeah.
And I know that the same questioner also wanted to know about the kind of contaminants in the harbor sediments. And there's reports on that there's a whole web page. And because of the contaminants, it cannot be deposited out at sea. And so they've put in it's called a confined aquatic disposal site.
Yeah.
CAD, I think that's what it stands for. I'm trying to remember the exact
Yeah.
acronym, but and so all the contaminated sediment will be captured.
Yeah.
Um,
Could I ask a question, or could I answer a question real quick? I saw one come through just because I want to get the link shared on the 2050 aragonite modeling. That's in, I forget what report that's in, but the
Science
state
and
of,
Technical Subcommittee of the Maine Climate Council
thank you.
looked at modeling scenarios, and they said under a high emissions scenario, which we're certainly trending toward now, by
Yeah.
2050, it's expected that there will not be year round, there will not be enough omega aragonite saturation in seawater for shell formation. And that's part of why it's so important for us to have a seat on the Climate Council and to be working with those
Yeah.
scientists and be part of that collaboration, because we're trying to address real problems. Not,
Right.
um,
Thank you. Yeah. I
yeah.
just saw that come through. I wanted to make sure we addressed it.
Oh, next question is really tough. Can you share why 2016 shows higher nitrogen levels than other years? Perhaps there was more rain that year.
That's,
I actually thought that was my first year. I kind of remembered that as a drought year.
I'd
And
have to go back and look. That's a great question. It is,
it's, of course, from Peter.
of
Um,
course.
Thanks, Peter, for stretching our brains. I seem to, I remember having discussions about that, and I know Angie Brewer is on
Yeah.
this program too. And it was my memory is it was very, very hot and very drought conditions, and it kind of like set up growth for these nuisance algal blooms. Like maybe there'd been a lot of nitrogen loading or something. But I
Yeah.
remember we didn't have a definitive answer, and it's part of why it's like a long-term study. Mike, does that
Yep.
sound like what we
That's
were?
that's about right. Yes. Yeah,
Okay.
I hate to say we're still working on it, but yes, it's one of those questions we do look into.
Next question. Is Friends of Casco Bay or another organization currently monitoring water quality at the mouth of the Presumpscot River?
One of our seasonal sites is where the water kind of ends up in Casco Bay, between the mouth of the Presumpscot and the old B&M baked bean plant. So that's what we use as our mouth of the Presumpscot reference site.
And I
Others
think in
do.
terms of other organizations, the Department of Marine Resources has P90 sites around there, right, where they're measuring
Absolutely.
bacteria.
Yep.
We saw some other gear there, but I don't know if we ever determined who else was doing that monitoring.
Right.
And then we and DEP have monitored just above head of tide using a continuous monitoring sonde in the sort of lowest freshwater segment before. It went, those are some other examples I can think of. So
I
the
know the
answer is
DEP
yes.
certainly has a site near there as well when they're here in Casco Bay.
Yeah,
East
so there
off
is
Macworth.
monitoring going on
Yes.
there. And there may be more over time. Okay, quick question. Are eelgrass and seagrass the same?
Yes, eelgrass is a kind of seagrass. There are other kinds of seagrasses, but Zoster marina, eelgrass, is one type of seagrass.
And in our area, it's really the predominant seagrass, right? There's some widgeon grass, but it's mostly
Correct. Mostly eelgrass. That's what we see here.
So it's a really good question because in other climates or other areas, they might be looking at more types, but we kind of focus on eelgrass. Okay, have you analyzed whether dissolved oxygen levels vary with tide, particularly in eastern Casco Bay during late spring and early summer? We have some tough questioners on this.
This is good. Yeah, and I'm looking at that actually right now. Yeah, the answer is yes. It's more pronounced in Portland, tidal influence on oxygen. It's trickier at our Harpswell site because we have a lot of influence actually from the Kennebec River, of all things. It kind of curls around Pittsburgh and ends up near that station. So we'll see changes in salinity, certainly, but also DO as a tide kind of moves that fresher water in and back, fresh water from the Kennebec. So the short answer is yes. Sorry. It is a very dynamic, very interesting system. But I was surprised at how much the tide influences a number of parameters. I'll leave it at that.
Okay. I want to ask you to answer this last question sort of quickly, because we need to wrap up. How do aragonite levels vary between your 3 monitoring stations?
Another good one. And you can see that data on our website. In addition to having all of the parameters graphed for each site individually, you can also see how the sites compare to each other on the same on graphs as well. They trend similarly. Portland Harbor always seems to be a lot lower. It's just there's more respiration going on there, and there's a little more acidification, it seems like, a little less oxygen, that sort of thing. So Omega Aragonite, Portland a bit lower, but they all tend to trend being higher in the summer. But check out our website, Tyler.
Yes. Well, speaking of our website, one of the reasons why we've been asking you questions as well about data is that we have received funding, and over the next 2 years, we're going to re-envision how we present data on our web page. And so we're really looking for feedback from people in terms of both the types of data you want to see on our web page and how you as an audience want to use the data and the web page. So please continue to share your thoughts with us, because we're really excited about this and we want to go beyond sort of where our thinking might be to be expansive and to have the best possible interfacing of or presentation of our data, best usable data for all of you. So we have one final in the series, the PFAS program. Please join us for that. That should be very exciting. We want to thank again all of the people who help support our funding, especially the Casco Bay Estuary Partnership, who always strongly supports our work and is one of our strongest partners. Sara and Mike, do you have any final words you want to say?
Thank you. Thanks to everyone. It makes this possible.
Okay,
yeah,
we are
thanks all.
right on time. It is 9 a.m. Have a wonderful day, everyone. Thanks for joining us.
Thank you.